Hello, Jay Vignesh along with the project mates Hariharan and Venkatesan. They are going to present a project paper presentation on distributed throughput application in wireless network with random power allocation. An objective of our project is resource allocation in wireless network involving solving a joint link scheduling and power allocation problem, which is very difficult in general. Due to this difficulty, most of existing in literature consider a simple setting where all nodes in the network use the fixed transmission power, and resource allocation problem degenerates into simply a link schedule. Furthermore, the link scheduling problem has been mostly studied as a simplistic graph-based interference model. Abstract of our project. We develop a distributed throughput optimal power allocation in the wireless network. The study of this problem has been limited due to the complexity of the underlying optimization problems that follows an efficient solution even in the centralized setting. We illustrate the performance of the power allocation solution through the numerical simulation. The existing system. Most of the existing system in the literature is considered a simple setting where all the nodes in the network is the fixed transmission power loss, and the resource allocation problem degenerates simply a link schedule problem. The disadvantage that in the existing system is resource allocation in multi-core wireless networks involves solving branch link and power allocation problem, which is very difficult in general. The system which we are going to propose, in every time slot, the randomization framework does the following things. First, RAND ATH, that is randomized scheduling, generate new random schedule, and decide is to schedule the current schedule by comparing the selecting better of the new and the old schedules. The advantage that exists in our proposed system is we consider the problem of achieving maximum throughput under SIN or rate-based model in multi-hub wireless networks. We develop a randomized power allocation that satisfies new optimicity conditions and distributive based comparison mechanism that achieves 100% throughput together with the randomized power allocation. The basic requirement for our project, coming to the software side, we need a system, the Pentium 4 processor with a speed of 2.4 GHz, and we need the hard disk capacity of minimum GB. The RAM minimum capacity is 256 MB. Coming to the software requirements, we need a Windows XP preferred system, and the front end tool as Visual Studio, and the back end tool, coding language is C#.NET. These are the base 4 modules of project. It's a network construction model. It's a very model. The resource allocation problem has been considered mainly in 2 different network settings. The first setting is to static one and does not make the randomness in the traffic or process in consideration. The second setting assumes the random arrival traffic, and one of the main objective resource allocation problem is to maximize the average arrivals which can be supported in maintaining the network stability. Second model is the SIN-based interference model. In this model, we assume the SIN or rate-based interference model, where the transmission rate of the link is given a continuous function of its SINR. To the best of our knowledge, there is no known work that assumes the SIN or rate-based interference model and solves the throughput optimal power in the stabilizer framework. Randomized power control framework. This is the third model of our project. In this model, we implement the following algorithms. First one is the randomized power control algorithm. That is RAND power. Generate a new random power allocation vector in the distributed manner. Next is decide. Determine the current power allocation by comparing the previous power allocation IP and the new power allocation and selecting the new one with the higher weight. The last model of our project, the wireless network simulation model. In this model, we developed a simulator for wireless networks which shows the features and the power value. The basic power value of the process rate with the 0.5 and with the packet is of the 2. The offered load is this. The parameter will change into exact performance. And this is the activity diagram of our project. First, initializing the process will be coming to the client. It is transferred to the source router, and from the source router it is transferred to the network router. In the network router, we need to select the optimal power, and after selecting the optimal power, it is transferred to the destination router. Then it will be transferred to the destination, and the process comes to end. Coming to the conclusion, we consider the problem of achieving maximum throughput under NR rate-based model. In multi-hub, in particular, we focused on the distributed implementation of optimal power allocation algorithm. Typically, this requires repeated solving an optimal power allocation problem by taking into account conditions and the queue backlog information. We developed randomized power allocation that satisfies the new optimality condition and a distributed logic-based comparison at 100% throughput together with the randomized power allocation. Thank you.